This is Brandon Jones with Pact Publishing. In this section, we're going to take a look at integrations. We're going to start by looking at making decisions and then an example of making decisions. Then we're going to discuss how parsing works, and then we're going to look at JSON, and then an example JSON parse. This will probably be one of the most important sections of the video course, as JSON parsing is not only very popular, but it's a good way to integrate data from outside sources into your application. So let's start with making decisions. And to be honest, we have a little practice with this because our last video did some decision making with a complex if test. So, why do we make decisions? What's an example of a simple if test? What if we had an alternative with an if-else? What about multiple alternatives? And then finally, what are alternatives to if tests in general? So first of all, why do we make decisions? It's a fundamental concept in programming because it allows our program to change the outcome based on certain conditions. And again, we've seen several examples of this so far. The example of using a random number to decide which button to light up as green. So, what we're going to do in our next example, which is our next video, is we're going to consider how do we know if the user chose the correct plant. A simple decision looks like this, where we test for a condition and we take some action only if that condition exists, otherwise we take no action. That is a simple if test, where we start, we ask a question, if the answer is yes, we do this. If not, we simply move on to the next step. We can get a bit more advanced where we have a one or the other or a mutually exclusive outcome where either one's going to happen or the other is going to happen. So in this case, we start, is Wi-Fi available? Okay, then I'm going to upload a selfie. If not, if I don't have Wi-Fi, well, I'm going to go buy a book and I'm going to read it. So I will do one or the other of these outcomes, but only one, and exactly one. I won't do both, I won't do zero, I'll do exactly one. I come into a decision, and I have a path to make based on the outcome of that decision, evaluating to true or false. Now, a more advanced situation is where we have multiple cases that we want to test for, and only one should be true. So, let's say I want to go downtown, and I'm looking at the money that I have or the budget that I have. Do I have less than $2? Well, I probably better walk. If I don't have less than $2, then I'm going to ask myself, do I have less than $3? Now, since I know I don't have less than 2, I must have more than 2. So really, this is a range question that's asking, do I have more than 2 and less than 3? If so, then I take the bus. Now remember, I'm only going to do one of these. So if I have $2.50, this will evaluate to false and I will not walk. This will evaluate to true because $2.50 is less than 3 and I take the bus. Now if I have $5, I don't have less than 2. I don't have less than 3. I do have less than 12, so I might park in a remote lot that's an economy lot that is far away. Now if I have $15, do I have less than 2? No. So I go to the next step. Do I have less than 3? No. Do I have less than 12? No. Then I might park at a premium lot, which is up close and has a shorter walk. That's similar to what we did in our last video where we said, pick a random number. Is it 1? If so, turn the first button to a green background, and then we'll skip all these else-ifs that follow. On the other hand, if our random number that we select is number 2, well then our first if test is going to return false because 2 is not equal to 1. Our second if test will return true because 2 is equal to 2. It will set the second button to a green background and then skip the third and the fourth. Naturally, if our number is 3, then the first test returns false, the second test returns false, the third test returns true, and then we go to our third button and change that third button background color to green. Now the very last thing that you see is an else if for random number equals 4. We're making an assumption here that we only have 4 buttons, and therefore our random number that we pick is going to be 1, 2, 3, or 4. So in theory, we could change this else if here to just an else, and we would get the same behavior as it is now. But I prefer having it as we have it here, Because what if we had a flexible design in the future and we had more than 4 choices? What if we had 5 choices, 6 choices, something like that? Also, this is a bit better documentation because we can see clearly what happens in each of these choices, 1, 2, 3, or 4. One thing that's probably a good idea is to go ahead and add an else part at the very end of this and add some kind of log statement that says we shouldn't be here or we shouldn't get here. That way, if our application starts to exhibit funny behavior, maybe no buttons are lighting up, we can take a look at the log statement and that else part and see what random number was selected. Is this something that was different because maybe we did our random number algorithm wrong? So it's not a bad idea to have that catch-all else part, even if you think all cases are handled by the if and the else if. So, in our next example, we're going to repurpose this a bit, and we're going to actually use this to evaluate the user's decision and then color up a button based on what the correct answer is. A few notes on avoiding the if statement. Honestly, we don't want to overuse the if statement, so one good idea might be to take anything that is specific to a subtype and create a subclass for that. In other words, instead of one big class with a huge if structure, create a bunch of small subclasses that know exactly how they operate, but don't know how anything else operates. Another example of an if test is the Elvis operator we saw in a previous video, where we know if we are trying to invoke a function on a variable that contains null, we can provide a default instead. So that's similar to doing an if test. Now, Kotlin also has a when, which operates similar to a traditional switch case in traditional programming languages, but with several added bonuses. This when can contain an else block, which a traditional switch case statement does kind of in a funny way. Also, a switch case assumes that you are going to hit a number exactly. A traditional switch case statement assumes you're going to hit a number exactly. Kotlin allows you to actually use a range to say, if the number falls between 3 and 4, let's assume it's 3. Kotlin allows us to use a not operator in some of our range conditions, and it also allows us to operate functions on our switch arguments and evaluate results. So if you're not familiar with the switch case statement, that might not all make sense, and don't worry, because what you can do with the switch case, you can do with the if test that we just went over. If you are familiar with the switch case statement, I don't have an example to show with each of these operations, but this gives you a bit of an idea of some advanced operations that you can do in Kotlin if you want to do some kind of conditional behavior and you want an alternative to the if test. That wraps up our high-level discussion on conditionals,